Okay, good afternoon, everybody. Welcome to our virtual workshop about Wolfram Alpha in the calculus classroom. This is Aish Vardhani, and I work in educational partnerships at Wolfram Research. Thank you for answering our poll questions. We're happy to see you here, and let's get started. So as you know, this workshop is about Wolfram Alpha in the classroom. From your poll questions, I gather that a lot of you are familiar with our technologies, and some of you are not. So I'm going to start with, for those of you that are not familiar, Wolfram Alpha is a knowledge-based computational engine. What that means is that Alpha computes a result to a query that you pose on the fly. So it accepts queries in natural language, which is awesome, and it computes on the fly. So let me show you what I mean. You should be seeing my browser now, so Alpha is accessible on the web. Just go to wolframalpha.com, and you can ask it any query in natural language. So supposing I have a burning need to find out the calories in an apple. So I just type that out, and as you can see on the screen, it's computing, and it gives you the result. It does more than that. It gives you a lot more information than probably you wanted. So this is a quick, 10-second what is Wolfram Alpha. But then let's talk about a more interesting query that you can ask it, right? Not calories in an apple, but something that actually involves Alpha having to compute something for you. So how about if you asked, how many tennis balls fit in a swimming pool? And then if I wait for the result here, you see that Alpha has interpreted your natural language, plain English input sentence into, okay, I need to estimate this quantity, and you can see the estimation data here about the interior volume of an Olympic-sized swimming pool and how it calculates the results. I also find this very cool that it actually gives you a range of values between these two numbers, because it also depends on how tightly you pack the tennis balls in the swimming pool. So this is Wolfram Alpha, and it's the underlying technology behind Alpha is the Wolfram language, which, again, some of you have indicated you're familiar with it and some of you are not. I'm going to be talking a little bit more about that later in my presentation. So moving over, this page here should give you a general overview of Wolfram Alpha and an idea of the topics that Alpha can cover. So obviously, we're born and raised to do math here, chemistry, music, shopping, surprises. So if I was to click the math section, actually here there's a general examples page that you can see on my screen. So these are the different subject areas in which Wolfram Alpha has tons of data, and it can compute your queries for you. Of course, today we're interested in math, and even in math, as you can see, we have all these different areas, and we're going to be focusing on calculus and analysis over here, sorry. So one thing that I want to point out before I move over to my example that I want to do next is related Alpha blog posts. If you're familiar with Wolfram at all, you'll know that we try to very active in posting blog posts, and we post a lot of interesting articles and blog posts all the time. And when you search for a query in Alpha, you're almost always going to find a related Wolfram Alpha post about that as well. So I encourage you to check those out. So okay, so let's look at an example of a proper math calculus problem that Alpha can handle. So if I was to just be lazy and just choose this integral that I see over here. If you want to integrate x squared sine cubed of x, then obviously Wolfram Alpha can do that for you. It can plot the curve, and it can estimate it for you. It gives you alternate forms of the integral, and it also gives you, okay, so if you're talking about a definite integral, then what does that evaluate into being for different limits? One aspect of Alpha that I would like to talk about here is step-by-step. Step-by-step solution, when I click that button, rather than just giving me the answer like you saw on the previous page, takes me through the steps that are needed to compute the results. So you can do this step by step, or I can just get it all in one shot. So it's an awesome tool to help you understand the underlying the mathematics of what is happening here, rather than just type in a question and then just get your result. I will point out that step-by-step solutions, this is a functionality of Alpha that is available when you have a Wolfram Alpha Pro or a Wolfram Alpha Pro Premium subscription. You can find more information about that on our website. So like I said, there's a lot of different areas in mathematics that we cover, but one of the, my themes with designing this presentation today is, okay, so you're a teacher and you have this new technology or to use in your classroom to inspire your students in calculus. One of the things that we see is, and I used to teach math before, and I've faced this question of, okay, why do I need to learn calculus? Or how is knowing the sign of x, or how to successfully integrate a function, how is that going to help me in any way? And we find that students lack that sense of relevance, which really kills their interest in learning a subject because they do not understand how to relate that to real life. And we see with Alpha that this is possible to do that. So that's going to be my first example today, is calories burnt while running. So it's actually a link over there, and you'll have a downloadable presentation for this, so this will be accessible to you later. So if I just type into Alpha, calories burnt while running, you see that this basically opens up a calculator-like box for you that says, okay, the time, 60 minutes, this is your pace. We're assuming that your gender is male, that you can change this, and some standard random body weight. And it gives you the energy expenditure of a 60-minute run done at this pace by a 159-pound guy. This is how much calories he's going to expend in order to do this. Well, okay, so this is my question in Alpha, but how am I relating this to my calculus class, right? Okay, so what if I pose this question to my students? I say, okay, so you're running, it's a particular duration that you're running for at particular speeds. You can calculate the calorie expenditure for this situation at different paces. But as you increase the number, the goal here is to try and estimate your pace and rate curve, put in a bunch of different speeds, let Alpha determine the calories, and to basically create a curve as a result of this and then integrate over that curve. With a lot of calculus word problems, once students figure out what is the formula that they're going to be needing to solve that problem, it's a quick matter of, plug those values in and then, go through the motions of substituting that formula and you're done. Here, you're having them play an active role in not just solving, but in creating the problem itself. You need to know what to put into the integral to get an understanding of what it is you're trying to do here, rather than just have a stock integral given to you and say, evaluate this at these different points. So you can have them enter this information in. So let's say that I start at, it takes me 10 minutes to walk a mile, and I do this for 60 minutes. I'm not changing the other information in here. And this is my, it takes me 946 calories. So that's one data point that I have now. What if I typed in 1 over here and hit enter? So Alpha's computing again for me, and the input information is summarized here in this box, but you see that the result, the speed, is outside the normal range for a human. So it's important to understand here that Wolfram Alpha is not this blind number crunching super calculator, right? It's got a ton of data behind it, and it's understanding your query and computing a result for you, rather than just plugging in certain numbers into certain formulas and just spitting out a result. So when you type in that, I'm walking 1 mile in 1 minute, then it knows that that's not realistic for a human. So let's type in some more realistic numbers here. Go back to 10, and I have a number. And then I for the next 10 minutes, let's say I'm walking, it takes me 12 minutes to walk a mile. So you get the idea, where you are creating now a bunch of different data points, collecting data on that, and with that you're going to be getting a curve. Yes, it's not a continuous curve. You're going to have to integrate over that curve. You're building the need for a Riemannian sum, rather than just giving them a already well-defined integral or a already well-defined curve and saying, integrate over this curve. So we see that understanding a calculus math problem from this lens gives you the tools to gain a mathematical intuition in understanding these word problems. They're usually, I know that they're usually a tough beast to tackle in calculus classes, and giving them the control that, here, this could be you running. This could be, so change this to a female and put your weight in and your age in, and this could be you who's actually doing this experiment. And it's just, I feel, a more involved way to do calculus. Physically, can you extend this problem? Yes. Physically, what else changes when you run? So technically, your body weight changes as you run. So does your age. So even if I'm running for 60 minutes, my age changes as, those minutes pass. Immediately you're thinking, but hey, that's just insignificant. It does not matter that, I'm 2 minutes older than I was when I started this presentation. But that really depends on what kind of problem you're asking or what question you're asking. Maybe your age doesn't matter when you're talking about a few minutes of a difference, but supposing you were talking about building a part for a machine or designing a fan, and you know that this part degrades in time, knowing the rate at which something happens and understanding that a lot of minuscule different time steps can add up to something significant, that sort of mathematical intuition is important. It's easy to just dismiss it and say, no, the age is not a qualifying variable in this situation. But can you prove that mathematically? Can you say that when a runner runs for 60 minutes, the fact that they are aging in the span of that 60 minutes is mathematically insignificant? It's an interesting problem to give your students. And with a tool like Alpha, they have the necessary toolkit to answer those questions, because with Alpha they have access to a bunch of data that otherwise they don't. That's what I have to say about the calories burnt while running example. Another example I want to talk about is this one. How wet will I get walking in the rain? Now, before I actually click that link and take you to that Alpha page, I want to talk a little bit about how, in a lot of my calculus classes when I was teaching, I would start with, here's a situation. And so often I'd have a student or more have a little bit of difficulty in understanding how this was relevant in a calculus setting at all. And that is exactly what I mean about mathematical intuition. When you pose a problem like this, how wet will I get when I walk in the rain? It's very hard initially when you're beginning to learn calculus to be able to quantify that and realize that this is actually a calculus problem. So when I type that question back into Alpha, just waiting for it to load here. So it's computing for me. And there are your parameters. Obviously, any attempt to answer this sort of a question depends on the height, the width of the person that's walking, the speed at which they're walking, obviously, how far they're walking, what is the speed of the rain, the angle of the rain, and the rate of rain, and so on. And is it possible to have formulas for this? Yes. So when you scroll down a little bit, you see that there are a ton of formulas, starting with, of course, the most basic: time equals distance over speed, distance over velocity. But you have all these other formulas and their associated parameters that you get here. Now, what can you do with this sort of a scenario in your class? Can you have your students analyze? I'm just going to put this box back here. Can you have your students analyze how this equation changes if the rain speed changes? So if I was to increase my rain speed a little bit, well, plug that into your calculator, change your input parameters, and see what happens. So you get a result, and plot it and see how this behaves. Can you predict what's going to happen if I change my input parameters a certain way? there's another interesting feature here about curves. So here you see speed versus wetness curves, which depends on, obviously how fast you're walking and how wet you end up getting. And you see how these 4 different curves are shaped very, very differently. An interesting exercise would be to have your students investigate why this is so. Right, so you give them the data, you give them a tool in which they can play with the data, and then you ask them a few telling questions. Okay, so why is this behaving the way it is? Can you see the need for integration over here, or do you just think of this as a simple, I'm going to multiply the distance with the time, and that's going to give me the answer that I need? Why is this different from a normal algebra question? Well, they need to develop that understanding that here everything is changing, right? This is a classic rate of change problem. The rate of speed is changing. The amount of rain per unit of time is varying. All of these quantities are changing. And so you're not going to be able to evaluate this with a simple multiplication. Here, like I want to point out this formula, WY, which is, so you go down here, you see that this is wetness for the sides. And this formula, D over V. D over V, this is a time. This is a time component over here. Rho, what's rho? Rho is your density. So that is the rain density over here. And there's a formula for that right above as well. So you have a time component. You're multiplying that with a density component. And then you have an absolute Vy. HD. So you have, you understand what these things are. So Vy is the rain speed along the y-axis, along the y direction. And then you have H and D, which is the height of the person and their shoulder width. So when you have this quantity, Wy, and you see that this is the formula that it has, to have that intuition that, this is an integration problem where you're basically needing to integrate this quantity, rho times VYHD over dt over your time steps specified by D over V. It's just another way to think of how wet do I get walking in the rain. So understanding how this is a calculus integral as opposed to an algebra integral, and so on. That is my second example. A few more ideas for your math class that utilize the amount of data that we have in alpha and the kind of queries that alpha can process for you. Where would the balloon go? Well, before I click on this link, I'm just gonna give you a little bit of a backstory. Some of you might be aware that we host an annual summer camp out in Boston called the Mathematica Summer Camp. This is an annual event that we do for high school students where for 2 weeks we have about, I think, 40 students who attend summer camp, and they work on a programming project using Mathematica. A lot of them have not seen calculus before. Very few of them have programming experience, and it's an awesome time. They have lectures, they work on their independent projects, and so on. So one of the things that happened this year, a student was posed the question, okay, so you have a point balloon. To make things simplified, let's just assume that your balloon is a point. And what you're doing with it is you're releasing the balloon at a particular time, at a particular spot, say Washington, D.C. Can you figure out where that balloon's going to end up in 1 week or in 2 days? So what kind of information do you need to be able to begin answering a question like this? This kid had no calculus background and I think a very minimal programming background. There is a lot of historical wind data information in alpha. So if I type wind Chicago, look at the result that I get. I get the current weather information. But if you scroll down, you see there's the history and forecast graph that talks about the wind information for the current week. But that's changeable. I can just go to the past year, and then this graph is going to update with, it tells me what the wind was like for the past year, and I believe this goes back a long time. I can go back as much as 10 years or more. And now I have access to historical wind data. And the project that I'm talking about was also done using a little bit of Wolfram Language programming to access the data in alpha and to I think he assumed that this was a unidirectional balloon that moves only in, let's say, east or something. And he was able to build a very powerful little application that was able to answer this question. Say you released a balloon at noon on the 2nd of August in Chicago. I can tell you where that balloon's going to end up 1 week later. And to have a student do something like that in a span of 2 weeks, it's a matter of being able to ask the right question and to have access to information of the kind that you have in Wolfram Alpha. So you have historical wind vector information for a bunch of different places. How are you going to exploit that information to answer the question that you want? Another interesting activity would be the reading speed and the length of words. So this question in Wolfram Alpha, how long does it take to read Hamlet? So can you use the result of this query? And it's going to tell you a very, very long number, I think. Yep. So there's about 30,000 words in Hamlet and about a little under 5,000 unique words. And knowing this and having an idea of how long it takes for you to read a word of a certain length, how long to read it, calculate how long to it would take you to read a text when your reading speed depends on the length of the word. So can you access information like this from Alpha to answer that rate of change question? Another interesting question would be how much carbon is in the air. So I'm going to click that link over here, and it's going to give you a graph about the global carbon dioxide level. So can you give this information? So you give your students Alpha. You ask them questions that spark off a mode of inquiry into other areas. So you give them this data, and what does it, what questions does that data spark? How much of carbon has been put into the atmosphere in this year? Knowing this information, can I extrapolate into what's the situation going to be like a few years from now, 5 years from now? And how would you do that? You need calculus to answer those kind of questions, but my guess is, and I think that this is an ethos that we all share here at Wolfram, is that if you give your students access to real-world data, then they're going to be more invested in answering these kind of questions that they have, rather than doing stock word problems or stock questions that have, okay, I need to know what formula to plug in here, and I'm going to plug in that formula, and then I'm done. So this allows them to direct their mode of inquiry in a way that they're leading it. And I think that that's very empowering in a classroom to have students do that. Another thing that they're going to face when they begin to work with real-world data, and I'm sure that the people who are listening to me, you guys have been in this situation before, is you faced a situation where you're dealing with a lack of continuous functions in real-world data. When you're talking about how long it takes, the calorie information when you run, or the walking in rain, or even the balloon and the wind information when you release a balloon in Chicago or something. These are not continuous functions. You end up with a bunch of discrete data points, and you need calculus to be able to deal with a situation like that by taking data as is and either incorporating that into a Riemannian sum, or you need to teach them about how to interpolate data. And when they deal with real-world data like this, they understand the need to do that in the first place, because you don't have these textbook functions. You don't have textbook examples where everything is continuous and everything is smooth and all you have to do is apply your formula. Rather, you're dealing with a real situation that needs calculus to deal with. Let's go back to my presentation here. So these were some of the ideas that I thought would be interesting to throw out as a way to use Alpha in your classroom. Another thing I want to talk about is the problem generator. The Wolfram Problem Generator is a tool that generates random problem sets with a single button click. So it's also accessible on the web. Just go to wolframalpha.com/problem generator. What the problem generator does is, across a bunch of different subject areas, it's going to generate individual problems. So since we are dealing with calculus today, I'm going to go down here to calculus, and say, give me a problem set about, let's say, the product rule. And when you do that, it asks you a question. It asks you immediately, related to the product rule, how do you differentiate this function? You're going to have to treat these two as two different parts of a function. Use the product rule in order to do this. And suppose, I'm not going to do that. I'm just going to say, this is my answer. It's going to instantly evaluate that for you and say, nope, that's not correct. And it gives you a hint. This is what you need to do to be able to tackle this question. And so this is the problem generator. It's available for free just on the website on wolframalpha.com. But there's another feature here that as educators you might be interested in, is being able to generate a worksheet that is just a printable problem sheet on this topic. So when I click the button down there, it's generating a PDF of a problem set in this topic, the product rule. And I think it has 20 problems. Yes, it's got 20 problems. And these are computed on the fly for you. So the next time you do this, it's a random set, so you're not going to see the same problems again. And they have an answer key as well. And this is printable. And I think that this is another useful resource to have, is to be able to allow your students to practice more problems. So this is the problem generator. And to be able to do the individual practice problems, that's available for everybody online. If you want to generate the whole problem sets with the answer keys like I just showed you, that requires a pro account, as well as the step-by-step solutions that I started my presentation with also requires a pro account. A couple of other Wolfram Alpha features that are relevant to educators. I already spoke about Pro and Pro Premium, but this is very interesting. Add-ons to Google Drive. This is a feature that we released just a week or a couple weeks ago, and this allows you to add Wolfram Alpha capability in your Google document or your Google Sheet. So you can basically install a Wolfram Alpha add-on to your Google sidebar, and you have access to being able to compute in your spreadsheet. So supposing, I hope you guys can see this clearly. Supposing, you have a spreadsheet where you're entering calorie information. The first thing I showed you was calorie of an apple, right? The calorific information. So rather than looking for that and then typing that in, you can just automatically place a Wolfram Alpha call inside your Google spreadsheet, and it's going to give you the result of that in your spreadsheet. If you want to read more about it, there's a really nice blog post that one of my colleagues wrote here about introducing Wolfram Alpha to your Google Drive. So I encourage you to give that a look and try that out. By bringing Wolfram into your classroom, one of the questions that we asked you in our polls was this about, not necessarily Wolfram, but how do you feel about using technology in your classroom? Are you on the fence, or are you convinced of its value, or are you very supportive of this, and you're like, yes, this is where the world is going today, and my students need to be equipped with digital tools for today so they can be prepared for tomorrow. Well, if you're interested in bringing Wolfram technologies into your classroom, we're here to help. We have a Wolfram grant program for schools, so you can contact us at this email address over here, and I think we'll put it on chat as well so you guys can copy that. This is a program that offers deep discounts on our technologies for schools and districts, so we're happy to have a conversation with you to understand your needs better and to see how we can help get our technologies into your classroom. So do write to us, and we're happy to help out.